Welcome to Learniverse. In today's session, we will explore one of the foundational topics in C programming, storage classes. This knowledge is crucial for understanding how variables work in terms of scope, lifetime, and visibility. Let's jump right in. In C programming, variables are not just about storing data, they also come with a set of rules for their lifespan, accessibility, and visibility. These rules are governed by storage classes, and there are four main types we will cover today: automatic, register, static, and external. Each has its own unique purpose, and by the end of this video, you will know exactly when and where to use them. Let's start with auto storage class. By default, variables declared inside a function are automatic or auto. These are local to the function and exist only during its execution. Once the function ends, they are destroyed. Here is the syntax and a simple example. Notice how the variable is created and destroyed within the function. A practical use case might be temporary variables like counters in loops or calculations. Think of auto variables as disposable paper cups. Use it for a single purpose and discard it afterward. Next up is the register storage class. Variables declared as register are stored in CPU registers if available, making them much faster to access. These are ideal for performance critical tasks. This is the syntax of register storage class. For example, a loop counter in an algorithm that runs millions of times, by declaring it as a register, you can improve your program's speed. It's like having a VIP pass to the CPU, giving priority access to the most frequently used data. The static keyword is incredibly versatile. For local variables, it retains their value across multiple function calls, extending their lifetime beyond the function's execution. For global variables, it restricts their visibility to the file, ensuring better encapsulation. Here is the syntax of static variable. Here is a local static variable example. It is perfect for retaining a function's state, like counting how many times the function has been called. Here you can see we are calling example functions 3 times, and you can also see the output, what exactly it is giving each time when we call the function. Global static variables, on the other hand, useful for maintaining data privacy in large projects. It's like having a personal journal that no one else can read. Finally, let's discuss the extern storage class. This is used to declare global variables that are defined in another file. It allows you to share variables across multiple files in a project. This is the syntax of extern storage class, and you can also see an example how the variable is shared between different files within the project. For instance, in a large application, you might have configuration variables shared between modules. Extern is the keyword which will make this work seamlessly. Think of it as a shared Google Doc accessible by multiple collaborators. Here is a side-by-side comparison of the four storage classes. This table highlights their differences in terms of scope, lifetime, and visibility. Pause here to take a closer look if needed. That wraps the session on storage classes in C. Remember, choosing the right storage class can make your code more efficient and easier to manage. I hope this video helped you understand the topic better. Don't forget to like this video, share it with your friends, and subscribe to Learniverse for more insightful programming content. See you next time.